Almost half of Alzheimer's patients carry the same gene. Most of them never knew, and if you carry it, it isn't fate, it's a head start. Hi guys, if you don't know me, my name is Dr. Lily Johnston. I am a board certified vascular surgeon, but I specialize in cardiometabolic prevention, so hopefully you will never need me as a surgeon. Today, I want to talk about the ApoE protein. It's also called apolipoprotein E, and this is a protein that your body makes and it runs your brain's lipid system, which is kind of cool because your brain is only 2% of your body weight, but it's actually 25% of the cholesterol in your body, but it's sequestered behind the blood-brain barrier, and so it requires its own very specialized lipid transport system. But ApoE actually works throughout the body, not just the brain. And that is going to be a really important part of the whole story that I'm going to tell you today about ApoE, why it's special, where it came from, and how we can understand why it's working the way that it is. So even though we almost exclusively in 2026 talk about it in the context of the brain and the lipid trafficking system in the brain, you need to know that it is also found everywhere. It is in our circulatory system. It can be responsible for early onset atherosclerosis or plaque formation. The liver is where ApoE is formed. It is very active, as we'll see later, in the intestines and in the immune system, right? So the immune organs like our thymus, our spleen, our bone marrow, ApoE is very active in all these places. But for what we're talking about today, which is risk for Alzheimer's dementia and potentially related dementias, the system in the brain is really where we want to pay close attention. So there are three different versions, possibilities, for which ApoE protein you can carry. There is ApoE2, there is an ApoE3, and there is an ApoE4. Now, this gets a little complicated because you get a gene for this ApoE protein from each of your parents. So in fact, you get 2 copies, and that means there are 6 different possibilities for the distribution of ApoE proteins that you have. 50% of yours could be from one parent and 50% from the other. So in this slide, I'm showing you the breakdown of all 6 possibilities and what their distribution is in the population. By and large, most commonly now is ApoE3, and about 70% of the population has a 3 allele. And then the E2, which is actually a little protective against Alzheimer's, but can be associated with some other lipid problems, is a small portion of the population. And then ApoE4, about 25% of the population carries at least one ApoE4 allele. About 2% of the population carries 2 copies of this. And when we look at the proportion of patients with Alzheimer's, we now see that almost half of Alzheimer's patients carry 1 copy of the ApoE4 protein. When did we learn that this was going to be a problem? In 1993, there was a team from Duke who was the first to connect this protein, ApoE4, to Alzheimer's. And what they found when they were looking at Alzheimer's patients compared to controls is that ApoE4 was wildly overrepresented. It was 36% in Alzheimer's versus 16% in the controls. But then when they went to autopsy confirmed cases of Alzheimer's, remember, our imaging wasn't quite as good back then as it is now, we actually saw upwards of 40%, and now we think it's closer to 50% of patients who have a diagnosis of Alzheimer's dementia carry an ApoE4 allele. This finding was replicated worldwide, and now, decades later, we have a number of other genes that are associated with the development of dementia and Alzheimer's, but ApoE4 remains the strongest common genetic risk factor for sporadic Alzheimer's disease by a wide margin. How much would it raise your risk if you had a copy? So if you have just 1 copy, if you have like the 3-4 genotype, you are at a 3 to 4-fold increased risk of Alzheimer's over your lifetime. If you have 2 copies, you are well over 10-fold, 12, maybe even as high as 15 times more likely to develop Alzheimer's later in life. The 1 copy issue or risk profile changes a little bit if your other one is an ApoE2, because I told you earlier, ApoE2 is a little protective against Alzheimer's. So if you are an E2, E4, this 3 to 4-fold risk is not quite applied to you. You could actually have a little protection. You could have a slightly increased risk above the 1x baseline, which is based on a 3-3 genotype. It's a little confusing and it's not totally clear to me exactly where your risk is. If you are a 2-4, you are a special unicorn case. You can come at me in the comments if that's you and we can talk about how we might better assess that. Otherwise, just know if you are a 3-4 and you just carry one copy of that 4 allele, it's a 3 to 4-fold risk. 2 copies, much, much higher, dose dependent on that APOE4. But the most important thing I have to say about APOE4, and I'm going to say this over and over again today, the most important thing about APOE4, it is that neither necessary nor sufficient to cause Alzheimer's disease. Just because you have APOE4, even 2 copies does not mean you are going to get Alzheimer's inevitably. Absolutely not. The whole point of this series is to talk about why it works the way that it does and what we can do to lower and mitigate this risk, because there are lots of people in the world with APOE4 who do not get dementia, plenty of them. And there is a lot we know today that we can do to minimize this risk for you. So let's carry on. APOE4 does not, I said this again, does not cause Alzheimer's, but it changes how much room your brain has to absorb everything else that goes wrong. So your brain is much less tolerant to metabolic and other insults, oxidative stress and inflammation. Your brain just does not have capacity to absorb those insults very well if you have 1 or 2 copies of this APOE4 allele. So what is it actually doing? Like, how do you think about this? How do we understand what's going on the inside? ApoE, as I said, is a protein. So it's a gene, and the gene codes for the protein. And the difference between the 2, the 3, and the 4 isomers of this protein are single amino acid changes. This is an almost 300 amino acid length protein, and just one amino acid changes how the whole protein folds, and it changes how it binds to lipids and their receptors. So you can look at this in more detail. I'm not going to spend a lot of time going through which exactly of these things happen, but just know very, very small changes change the folding of the protein and affect how it can bind to lipids and their receptors. You need to think of ApoE as a delivery fleet. So there are molecules in your brain that need to move from place to place, right? I told you it counts for 25% of your body's total cholesterol, but that's not a static molecule. That cholesterol needs to move around. The lipids in the brain are insulating the nerve sheaths. That's the myelin that wraps around to make sure that those signals travel all the way down. We need it in the synapses, we need it in the cell membranes. So this is a very dynamic process that's happening, and all of these lipids have to keep moving from place to place. And they can get used up or old or oxidized, and then they become a waste product. And just like your garbage has to get taken out by somebody and taken to the dump and then taken to the landfill, right? All of our garbage in the brain needs to get transported away from where it's causing a big stink and needs to move somewhere else. In patients who have ApoE3, for example, this is a very efficient transport system. Molecules get picked up, they get delivered where they need to go. It is kind of like the modern day Amazon Prime delivery service, right? Things just happen. They happen in a couple of days and it's all great. You don't worry too much about it. The ApoE4 delivery system is much more like, carrier pigeons several centuries ago, and a delivery system that works sometimes. It's definitely way less efficient. And because it's less efficient, a lot of the junk, that waste, begins to build up. And it builds up in an organ that does not love any waste products around, and it builds up in these synapses in the brain. So this becomes some of the junk that you see then on scans, and it's the amyloid, right? You've heard that if you've heard about Alzheimer's. You've heard about tau. These are the proteins that are trafficked with the lipid receptors and with lipids in the brain. When they're not cleared appropriately, they start to build up and gum up the works. So this undelivered lipid cargo does accumulate, and this becomes the plaque, the amyloid plaque that we see. And if you've heard about this, you understand the importance of amyloid. Now, We have drugs that seem to reduce amyloid, but they've been very disappointing in terms of outcomes for Alzheimer's disease patients. And why is that? It's because lipid transport is not the only thing that ApoE impacts in the brain. ApoE4 also impacts how your brain uses fuel. So when you take a look at the brains of people who are ApoE4 carriers, and you look at them in their 20s and 30s, long before they have any cognitive impairment, we see dramatic alterations in the brain's ability to process glucose and use glucose. The brain actually is a little insulin resistant in these people. And so even decades before you start seeing problems with memory or cognitive impairment, we already know that the brain's fuel system is less efficient. It is working differently. And this is part of a multi-hit hypothesis with respect to the ApoE protein. So you can have a perfectly healthy 25-year-old who carries ApoE4, and they are already burning glucose less efficiently than a non-carrier. But you have to ask yourself, if this gene is so problematic, if it is so dangerous, why would 25% of the population still carry it? Why hasn't natural selection cleaned this up? And now I want to take you to a really interesting part of the story, because you have to go back about 300,000 years to help answer this question. As it turns out, APOE3, the most common version of now, is actually the mutation. APOE4 was the original mainstream protein that was circulating. When we look at other populations, for example, let's go to Brazil. Let us look at children in a Brazilian shantytown who have chronic diarrheal illness as just a part of their everyday existence. If you study these children and you segregate them by who has ApoE4, who has ApoE2, and you look several years later, the children who have an ApoE4 allele are much more likely, 5 times more likely, to have higher cognitive scores than their ApoE2 counterparts or their 3 counterparts. They also have better weight for height ratios, meaning they do not suffer the consequences of these diarrheal chronic illnesses from childhood nearly as much as the other children. So ApoE4 is protecting the developing brains in these children and also their bodies through a very, very challenging portion of early childhood. What about human parasites? If you take mice that have the ApoE proteins expressed, you take mice that have ApoE3 expressed and then ApoE4, and you give them cryptosporidium, which is a pretty common human parasite, and you see what happens. The mice with ApoE4 manage to shed that parasite and kind of get rid of it. They don't lose too much weight. The gut lining is relatively preserved, whereas the mice with ApoE3 continue to shed the parasite, meaning they're not getting rid of it. They're not clearing it. They're losing more weight, and it is destroying their gut lining. So this is a huge immune issue for us as a species. We also can see that even independent of an immune system, if you just take the plasma of patients with ApoE4 versus patients with ApoE3, and you just put it in a test tube, and you introduce the malaria parasite, Plasmodium falciparum, and you take a look at what happens, the ApoE4 serum kills the parasite in 6 out of 7 of those test tubes, whereas the ApoE3 kills 0 out of 6. So you can see, right, infection after infection, how we would have selected to keep ApoE4 as our dominant ApoE protein over time. Lastly, look at hepatitis C. There are people who will spontaneously clear a hepatitis C infection. This is a virus that impacts the liver, and up until maybe a decade ago, it was pretty devastating because we didn't have good treatment for it, but there were known to be patients who cleared it. And if you take a look at the allele frequency, patients who cleared it are about 17% ApoE4, whereas people who are chronically infected are only about 10% ApoE4, which means patients who have ApoE4 are better able, more likely, to clear hepatitis C virus from their systems. So it is a very powerful immune regulator, in addition to trafficking lipids in the brain. So we now have 4 examples of different pathogens, different illnesses, different study systems, and it's all the same gene. But what's the common thread? And it's the immune system. So APOE4 retunes how your immune cells will respond to threats. And this has to do a little bit with lipids. It has to do with these things in the cell membrane called lipid rafts. So the cells have phospholipids in them, the cell membranes, but we also have specialized groups of them in a raft, right? Right. Think about Tom Hanks in Castaway building his little raft. There are special kinds of accumulations of lipids in the cell membrane, and the ApoE4 packs more lipids into the cell membrane, and it creates a stronger signaling mechanism for the immune system. And that makes the immune system much more it's got like a hair trigger. It really amplifies the reaction. What this means in the body is that at rest, patients with an ApoE4 system tend to run pretty cool. They do not have higher levels of chronic inflammation in sort of native populations, right? Not an elevation in hsCRP or more autoimmune disease. But when they get exposed to a pathogen, right, chronic diarrheal illness in children, parasites like Cryptosporidium or Plasmodium falciparum like malaria, then the immune system sends out a 4-alarm fire and really goes to town to clear that infection and help the body police these invaders. So now it should be clear that ApoE4 is not really a dementia gene by itself exactly. It's an immune modulator gene. And this is really the third hit in our multi-hit hypothesis for how ApoE impacts the brain. Because in fact, in the brain, there's much more of a pro-inflammatory signal. And you can imagine how that might happen, but we'll walk through it. Whether it's Alzheimer's disease, Parkinson's, frontotemporal dementia, we see greater levels of inflammation in the brain in all ApoE4 carriers, but healthy carriers don't have this. And so the disease is what happens when we are in the wrong environment. Because what we have, if you're an ApoE4 carrier, is an immune system that was built for pathogens. But now we are in a body, really in an environment that doesn't have any. I mean, it has some, but not anywhere like it used to. So this is the same immune system, but a very different enemy. We were designed when we had ApoE4 as the dominant allele for mosquito-borne malaria and contaminated water supplies and all of these childhood infections. But today, in 2026, we have high blood pressure and we have ultra-processed food environments and we have phones with notifications at 2 o'clock in the morning and the chronic stress of our everyday lives and forever chemicals in the environment. We have all kinds of new and different, much more chronic triggers than we were originally selected for. So this is 1,000 small alarms every day over the course of decades. And each trigger reads as a low-grade threat to a system that is tuned for an acute response. So the response is the same one that your immune system was trying to mount against malaria in the very acute phase. But this is just a never-resolving, never-ending stream of immune stimulation. Now, I said that at baseline, ApoE4 carriers are a little cooler on the immune system side in the body, but that is not really true in the brain. We see that the specific cells that are responsible for the immune system in the brain, the microglia and the astrocytes, they have higher levels of these inflammatory cytokines or these signaling molecules that help ramp up and sustain an immune response. And those are things like TNF alpha, interleukin 6, NF-kappa B, right? We see all of these markers are elevated in these cells in the brains of ApoE4 carriers. And so we get chronic, low-grade inflammation as the default state in an ApoE4 brain. This translates into a leaky or a permeable blood-brain barrier, right? This is what is supposed to keep your very precious, very sensitive, delicate brain separate from the rest of stuff that circulates in the body and might cause trouble. That blood-brain barrier is usually a very tight, well-regulated system. But in the setting of this chronic low-grade inflammation, these signaling molecules actually cause the blood-brain barrier to be a little leaky, and then we get those inflammatory molecules from the brain going back into circulation in the body, driving more inflammation there and feeding this back and forth system, and it becomes a self-perpetuating feed-forward loop. And this is, again, really problematic as we continue to be exposed to the chronic stressors of our modern environment that are driving inflammation. What I want to tell you, though, is that I can show you this is really a problem of our modern environment because there are much more like native free living populations who still have a fair amount of ApoE4 expressed in their genes, and they do not develop dementia. Like almost not at all, right? And these are folks who have a very traditional diet, higher levels of physical activity, the hunter-gatherer groups that are like not entirely, but largely untouched by our modern developed world. And in those groups, we have very, very low, if not zero, rates of dementia. You take that same person and you bring them into the Western world, into the Western metabolic environment, and now you do see that 3 to 15-fold increased risk for dementia in patients who carry the ApoE4 protein. So same gene, environment is what is pulling the trigger, right? The gene loads the gun, but it's our environment, this chronic inflammatory signal, that is pulling the trigger. I've told you we have multiple hits, right? We have this hair trigger immune system. We have the inflammatory metabolic state with insulin resistance. We have a brain running on less glucose. And these effects are probably not just additive, they are probably multiplicative. These are multiple things stacking up against us in the brain of an ApoE4 carrier. So the provocation is what we can change. This is what we have control over. The gene is fixed, right? We get that, we inherit it. It's all nothing we can do about that. We have a lot of control over our environment and how much stress we put on this system. And if inflammation is the engine, the lever for ApoE4 carriers is different because all of the metabolic interventions that have been tested for the prevention of dementia, like blood pressure control, exercise, nutrition interventions, they don't work less well in ApoE4 carriers. They work better in ApoE4 carriers. So this means whatever you choose to do about your environment and your lifestyle, if you have an ApoE4 allele, extra benefit for doing these things, not less. So every metabolic intervention that you make hits a higher leverage target in your body than for a non-carrier. You do not get less benefit, you get more. Your nutrition, your exercise, your sleep, your stress, all of this impacts you better if you are an ApoE4 carrier. Okay, this is something we have control over. You can move this needle. You want to know what all those things are, okay? We don't have time to do that in this video. We will do another video that goes through in excruciating nerdy detail all of the things that we can do to help reduce the chance of an ApoE4 carrier developing dementia. We're going to break it down into lifestyle. So, for example, things like the MIND diet, sleep optimization, exercise. We'll talk about the medical interventions. For example, what impact lipid lowering drugs might have, blood pressure control, multi-intervention trials like the finger study. We will also touch on supplementation because that's always a popular thing. I think it's the last 5% of what an ApoE4 carrier is going to benefit from, but absolutely we will go through all of these in the next video. Don't you worry. So knowing whether you carry an ApoE4 allele is a conversation you should have with your team. This is a genetic test. It should not be done without a little bit of thought, a little bit of care. And if you have a family history of a first-degree relative who has Alzheimer's or other dementia, it might be something you want to do. It can be a blood test or a saliva test. You might even get it covered by insurance. That's a little plus minus depending on your family history. But talk to your doctor about whether this is something that you want to get done. Many of you will also have genetic information from things like 23andMe. There are commercially available services where you can get this tested without going through a physician, but just be aware if you're going to get a result back and you don't have a relationship with your doctor and have a place to talk about that, you might find yourself in a situation where you have a result you didn't want and don't know how to get support. So just try to engage your team if your doctor is open to that. If you are interested in other content about genetic risk factors for cardiovascular disease, please go check out the series I did on lipoprotein little a. We will put a link for that up in the corner here for you. That is another great series where we talk about the gene, what it means, the protein, and what we can do about it. So let me circle back to this. Almost half of Alzheimer's patients never knew that they carried this gene. And some of you are going to tell me that you would rather not know either, and I get it. I totally get that. But what I would say is that knowing is the only thing that will turn this from fate into a head start, because you can change this. You have a lot of control here. And we're going to talk about how to do that in the next video. Until next time, guys, take really good care.